Okay, this is the motion application homework. This is from Unit 4B, kind of the part 2, and this is from the day 3, so over motion. So here a particle moves along the x-axis so that at a time t its position is given by this. So this is the position vector. So when you start with position, and then it's asking you about if the particle is moving to the right or the left. So we know that the particle is moving to the right when the velocity is positive and moving to the left when the velocity is negative. So we're going to need the velocity. So to go from position to velocity, you take the first derivative. So if this is my position, the derivative of that, aka the velocity, is going to be 3t squared minus 12t plus 9. Okay, so there's my velocity vector. And now I want to know if it's going to the left or right at t equals 0. So what I'm going to do is I'm going to figure out what the velocity is at 0. So I'm going to plug in t equals 0 into this velocity. So I get 3 times 0 squared is 0, minus 12 times 0 is just 0, plus 9. So that means I'm going to have 9. So this tells me that the velocity at time 0 equals 9. Since 9 is greater than 0, aka it's positive, we can conclude that the particle is moving to the right. So therefore, moving to the right. Okay, perfect. All right, next up, at t equals 1, the velocity of the particle, is it increasing or decreasing? So the velocity increasing or decreasing. So really that's a code. It's really asking you about the slope. Because the velocity being increasing would be if it had a positive slope, right? Positive slope. Or if it was decreasing, that would be a negative slope. So then you're like, well, what is the slope of velocity? The slope of velocity is the acceleration. So now I need to go from this velocity vector to acceleration. So I'm just going to write it up there. So that also tells me that the acceleration of this particle at any time, I take the derivative here. So that's going to be 6t minus 12. So that gives me my acceleration vector. And now it's asking me what's going on at t equals 1. So the acceleration at time 1 is going to be 6 times 1, right, which is 6, minus 12. So 6 minus 12 is going to be a negative 6. So what this tells me is that the slope of velocity at t equals 1 is negative. So therefore, it's decreasing. Therefore, decreasing. And that was kind of an interesting way to ask about it there. So the velocity, if the velocity is increasing or decreasing, that's really asking about the slope of velocity, which is the acceleration. Okay, next up, over what intervals is the particle moving to the left? So particle is going to be moving to the left when the velocity is negative, right? So left when the velocity is negative. So really they're saying, when is the velocity negative? Well, to know when the velocity is negative, you're basically going to be setting your velocity vector less than 0, right? So we've got the velocity is less than 0. So this you're just going to have to factor. So I'd first take out a GCF to make it a little easier to factor. And so you take out a GCF there, and then it easily factors into t minus 1 and a t minus 3. So you kind of got to think back to like our previous units on what does that actually mean here? We're going to have critical values, right? So whenever you take the derivative and you set it equal to 0, you're getting critical values. So I'm going to do this like a sign chart where my velocity, right, because that's the derivative that I took, and I know something's going on at 1 and 3 because I have those there. And so the velocity, if I plug in a number like 0, something to the left, so if I plug in a 0 into there, I get 0 minus 0, a positive. So the velocity is positive before 1. And then if you plug in a number like a 2, because that's between, so you're going to get 12 minus 24 plus 9, that's still going to be a negative. So it's negative when you plug in a number between. And then if you plug in a number bigger than 3, so like a 10 squared, that's going to be 300. So that's definitely going to be positive over there. So when is it moving to the left? When the velocity is negative. So it looks to me like the velocity is going to be negative between 1 and 3. Okay, so you would write that as 1 less than t less than 3 is when the velocity is negative there. And again, I'm answering the question over what intervals, so that's a time, and there's my answer. At which values of t is the particle changing direction? So direction changes when the velocity changes sign. So changing direction occurs when the velocity changes sign. So that means that it could go from positive to negative or negative to positive. Either one of those. Okay, well, kind of going back to that chart that I used up here, my velocity goes from positive to negative at 1, and then it goes from negative to positive at 3. So this changes direction at t equals 1 and at t equals 3. So this changes direction 2 times. It's moving to the right, then it moves to the left, then it moves to the right. Find the displacement. So again, the displacement you could integrate if you wanted. You could integrate the velocity, but your displacement, you could also think of it as your end position minus your starting position. So to figure this out, you have to take 2, and since your displacement, again, it's position, so you're taking this 2 and you're plugging it into, way back up at the top there, you're plugging it into this position. So it's going to be 8 minus 24. I might even do it off to the side here. So this is going to be 8 minus 24 plus 18 plus 11. So what is that? Negative 16 plus there, positive 13. I did that right? And then I'm going to plug 0 in. Well, that one's easy because when you plug 0 in up there, you just get 11. So that part's easy, right? Because you end up with 0 minus 0 plus 0 plus 11, right? So you get 11. So you're going to have 13 minus 11. So this displacement was 2, which makes sense because look, you are moving to the right, then moving to the left, then moving to the right. So your distance, right, would be more than 2, but your displacement, how far are you from where you started, is going to be 2 because you kind of backtracked. Okay. And down here, so the data in the table below gives the particle's velocity over time. So we have a classic velocity versus time graph. And it says the particle moving to the left or right. So you're given a table. All right, so you have a positive velocity, then a negative velocity. So at t equals 1, it's positive. So the velocity at 1 is 2. And again, 2 is greater than 0, or it's positive. So moving to the right. So positive velocity means your particle is moving to the right. Positive velocity means particle is moving right. Okay. All right, and then on to the next one. So we're approximating the derivative of velocity at time 5. Well, notice that time 5 is not even on there, but 5 would occur right there, okay? But time 5 is not even on there, and it's asking me to approximate the derivative of velocity. Well, the derivative of velocity is the acceleration, or you could think of it as the derivative of velocity is the slope of the velocity, okay? So this is the slope of the velocity, aka the acceleration. Okay? So if you're trying to approximate the slope, you can use your average rate of change formula. So we would say that that's going to be via, we can use 6 minus the velocity at 5 all over, 6 minus 5. And so you can get those straight from the table. So at 6, it was negative 4 minus a negative 2. Watch that double negative there, all over 2. So I have, that's a negative 2 over 2. So I have an acceleration there of negative 1. So a negative acceleration or a deceleration, okay? So here the acceleration at t equals 5 is approximately negative 1. Remember, this is an estimation there, okay? So I should have my estimation equal sign there. Okay, and that's the first page. So now we'll flip it over and go to the back. Okay, so looking at number 3, so you have the graph. So the first homework problem, you were given the equation. The second homework problem, you are given the table. And the third one here, you're given the graph. So it's kind of 3 different ways they're going to ask you about this motion. So in words, let's talk about what's happening here. So you have a positive velocity, and then you have a negative velocity. So you're going to the right, and then you're going to the left. That's what's happening here. So it's asking me first about the t equals 10. So at t equals 10, so here's time 10. You'll notice here the velocity is negative, so the velocity is less than 0. I don't know what it is. It looks like it might be about 10 or negative 10 or so, but in any indication, it's negative. So a negative velocity means that the particle is moving to the left. Now it's asking me at 10, is it speeding up or slowing down? Explain. So we want to have the velocity and the acceleration to have the same sign if it is speeding up. So if your velocity and acceleration have the same sign, meaning they're both positive or both negative, then it's speeding up. That implies speeding up. If they're different, that means it's slowing down. So how do I compare those? Well, here the velocity is positive. Now the slope here is positive. So from 0 to 5, you're speeding up because both the velocity and the slope of the velocity are positive. Okay? From 5 to 8, the velocity is positive, but the acceleration, the slope of the velocity is negative, so it's slowing down right here. Then you're speeding up again because look, we have a negative velocity and a negative slope, so it's speeding up in this section. And then you're slowing down here because the acceleration is positive, but your velocity is still negative. Another way to think of it is looking at the graph is if you are approaching 0. Here you're getting further away from 0, so you're speeding up. Then you're getting closer to a velocity of 0, so you're slowing down. You're speeding up because you're getting further away from 0. Then you're slowing down as you get back to a velocity of 0 again. So at what time, or it's asking me at 10. So at 10 specifically, right here, the acceleration is negative and the velocity are both negative. So you could say that the velocity at 10 is less than 0, and the acceleration at 10, the slope of the velocity, is also negative, therefore speeding up. Okay. At what times does the particle change direction? So remember, you change direction when velocity goes from positive to negative or negative to positive. So here your velocity is positive, and then it switches to negative right at 8. So at t equals 8, you change direction. Find the displacement of the particle from 0 to 12. So displacement is going to be the area under the curve. So we're going to have to integrate from 0 to 12. You integrate the velocity over time. So here you can do that using just triangles. So you have base times height, so 1/2, and then the base is 8. The height was 10, and that's positive, so that piece is going to be positive. And then plus, now you have this lower piece, so this base is going to be 4. Okay, so it's 1/2. The base is 4. The height is negative 10. I kind of view my height as the negative. I know some people put their negative elsewhere. It doesn't really matter. So let's see. That's 40 minus 20. Right? That gives me a 20 there. So my final answer there is 20. Now, how is that going to be different than the distance? I expect my distance to be a larger number because, look, I was traveling to the right, and then I kind of turned around and started going to the left again. But I'm still, if I was on a Fitbit, it's kind of, the distance is like your total steps. So algebraically, it would be the absolute value of the integration of the velocity over time, aka it's going to be 40, and then it's going to be plus the absolute value of negative 20, so your distance traveled is 60. Okay? So that about sums it up. And again, when does the particle change direction? So that occurs when the velocity goes from positive to negative or vice versa. And that is what you need to know about motion. Have a great day.